Everybody has an idea of what is motion. Everybody has an idea of what is speed. Everybody has an idea of what is velocity. But, in fact, everybody has an idea of what is acceleration. But here in this video, we're going to work about what are these definitions according to physics, and then you can use them appropriately in your lifetime. Okay, because I have noticed that many times you people or many people or other people, they compare velocity with acceleration or speed with velocity or displacement with position, and for some type of exercises in physics or for some type of things that you talk in your life, it's better to use the appropriate term. So we're going to make the definitions of these magnitudes, and then I hope that you have a strong idea of what they are. So as an exercise, please pause this video and write your definition of the terms that you can see there: position, displacement, speed, velocity, and acceleration. Go! Okay, we're going to start talking about position and displacement. Position and displacement. So, when do we talk about position and when do we talk about displacement? We talk about position when we're talking about, we can say, location, okay? Where is the object? Okay? And displacement is highly used when you want to say if position change. Okay? Displacement is change of position. If the object change the position. So let me show you that with an example. Let's say that here we have a reference, could be a stop sign, okay? And that's going to be our reference. And there's a guy here that is 5 meters from the stop sign, okay? So his position is 5 meters to the right of the stop sign. So notice that position is going to have a direction, because I can say that is 5 meters to the other side, okay? So to the left. So I have to tell what is the direction of the position. This is not the displacement. Displacement is when, I don't know, after some time the guy is here. Now it's at 7 meters from the stop sign, and displacement is this change, okay? This change of position that is going to be 2 meters. So look at that, the new position is 7 meters, but the displacement is 2 meters. Displacement is related to the change of position, okay? In some books, the displacement is written not using this notation, but an S. Okay, let me use red, S. So in this case, we can use S as displacement, or we can use change of position to understand displacement. This triangle means change, and X refers to position. Okay, so displacement, change of position, position, where is the object? With respect to a reference, of course. And that's the first thing. So you can write now the definition or check the definition of position and displacement and see if you have the same answer. And now let's move to the other two terms that are speed and velocity. Okay? In common terms or in plain terms, I'm not going to go to another part of physics, just not going to talk about directions a lot, but in plain physics, velocity refers not only to the change of position through time, that, you know, in using another notation, let me use red for the notation, displacement over time, but it refers to the direction as well. Okay? So velocity is going to have a direction. It's not the same because it's going to measure the displacement, and the displacement has a direction, but you have to tell not only the measurement of change of displacement and time, but also the direction. And in the speed, we don't take care of the direction. We're going just to take the distance traveled divided by time. Okay? So let me show you an example of the difference between speed and velocity. So let's use our guy. This is the stop sign. We said that the guy was at 5 meters. And let's say that after 2 seconds, so after 2 seconds, let's say that here we have a clock. The clock says 2 seconds. After 2 seconds, our guy is now here. So it passes from 5 meters to 7 meters. And now let's say that after another 2 seconds, so let's say that 4 seconds, here is 0 seconds. And after 4 seconds, our guy go here again to the 5 meters. So it moves 2 meters to the right and then goes back. I'm sorry. And then goes back, okay? So what's gonna happen to the distance traveled by the guy? The guy moves 2 meters here, then he went back 2 meters. So the distance traveled was 4 meters, right? And it took 4 seconds. So the speed is going to be 4 meters over 4 seconds. The speed is going to be 1 meter per second. So this guy moves at a speed of 1 meter per second. But now let's determine the average speed, the average velocity. Okay, the velocity. The velocity of the object after 4 seconds, what is the displacement? He went here, go back, but now he's in the same position, so the displacement is 0 after 4 seconds. So it means that the average velocity is going to be 0 meters per second. So as velocity has a direction and talks about the displacement, in this case, the velocity is 0. Really cool, right? So velocity includes displacement over time, and speed includes distance traveled over time. Okay? Look at that. For example, if we took just 2 seconds, we can determine the velocity and the speed. So as an exercise, why don't you stop a little bit, pause this video, and determine the velocity and the speed, and show me in your comments what is the velocity and the speed after 2 seconds. Okay, it's gonna take you nothing, half a minute. So this is my invitation for you to do it. And finally, we're going to determine the acceleration. Acceleration is related with the change of velocity. Okay, change of velocity. So if you change the velocity of an object, the object will be accelerated. So let's say that our guy, the stop sign is here, but our guy starts moving at a velocity of 2 meters per second, but when he reaches here the 7, he starts changing the velocity on the other direction to be negative 2 meters per second. Okay? So after 2 seconds, the velocity change. So the acceleration will be the change of velocity. That will be average acceleration. The change of velocity will be that starts at negative 2 meters per second minus 2 meters per second in 2 seconds. That will be minus and minus, minus 4 meters per second over 2 seconds. So minus 2 meters per square second. So that's the acceleration. The acceleration of the object is going to be negative 2 meters per square second. So it means that the velocity is changing, becoming negative, small until it changes to a negative. That's the average acceleration. Obviously, in advanced physics, we're using the terms instant velocity and instant acceleration, that is the velocity at one point. So at one point we can know how is the change of position through time, or the displacement through time, and at some point we can know what is the change of velocity through time. But for this we need to know a little bit of calculus that I'm not going to talk here. So far this is average speed, average acceleration, that refers to changes of the speed, the velocity, the acceleration, and the speed displacement over time. Okay, so I hope that this video gets you clear the concepts of kinematics, that are position and displacement, speed and velocity, and finally acceleration. Okay, so review your concepts, the things you wrote at the beginning of the chapter of the video, and now revise to see if your answers are appropriate according to the definitions or not. Remember to use the word velocity when you're talking about change of position, and acceleration when you're talking about change of velocity. Okay? So see you in the next video. We're going to talk about graphs, so I hope that you understand the topic. If not, write your comments. You know that you can follow me on any of my social network. This is my social network, so you can find me there, and see you in the next video. Goodbye. Have a nice day.